your first part of 13.6 goes over Pascal's triangle. What Pascal's triangle is just another way to be multiplying these binomials that are raised to powers. You'll see that there's a pattern that happens here with Pascal's triangle, and all of your numbers on the outside are all ones. From there, if you look at the third the third row, you have 1, 2, 1. If you add the 1 and the 2, it gives you the 3 that's directly underneath it. Same thing with the 2 and the 1 on the right, it's directly underneath the 3. As long as your number on the outside is a 1, you can add the 2 numbers that are above the one that you're trying to find in order to get that one. So you'll see that the 1 and the 3 give you the 4 from the fourth power. And then the 3 plus 3 is the 6. The 3 plus 1 is 4. And then the 1 goes on the outside. For the fifth power, you'd have the 1 on the outside. The 1 and 4 give you 5. The 4 and 6 give you 10. Then 10 repeats itself, 5 and 1. If you were to keep going with that sixth power, you'd have the 1, the 6, 15, 20, 6, 15, 20, 15, 6, and 1, and so on. Then the last row is just the seventh power. So the 1, 7, 21, 35, 35, 21, 7, and 1. This is 1, 7, 21, 35, 35, 21, 7, 1. So it's either going to mirror, both sides are going to mirror depending on how many terms that you have. In this case, you have 8 terms, so the 4 terms literally mirror each other on both sides from the middle. If we look at the first example, it tells you to find the expansion of a plus b to the 7th power using Pascal's triangle. Now, the way that you can do this is you are going to rewrite the first term within the binomial to the highest power. Then to the right of that, it'll be to the next highest, and so on, all the way down to 0. Underneath that row, you're going to write down the numbers from Pascal's triangle for that power. Then on the last row, it'll be the last term in your binomial raised to the power of 0 all the way up to the highest power. So what that means is that you're going to have this a plus b to the 7th power. You're going to start with a to the 7th power. Then you'll have a to the 6th, a to the 5th, a to the 4th, a cubed, a squared, a to the 1st, and then a to the power of 0. Underneath that row, you are going to write down the numbers from Pascal's triangle. So we start with 1. Then we have 7. We said that it was 21, 35, 35, 21, 7, and 1. Because look at your Pascal's triangle. So from here, you're going to rewrite the b to the power of 0 all the way up to the highest power, which is 7. So that's going to be b to the power of 0, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th, b to the 5th, b to the 6th, and b to the 7th. Before I do anything else with this, I cross out my powers of 0. So that b to the power of 0, I cross out. That a to the power of 0, I cross out. And then I'm going to multiply each of my columns. So that a to the 7th power is a to the 7th power times 1. Then we have a to the 6th power, which is a to the 6th times 7 times b to the 1st. So that's just b. Next, we have a to the 5th times 21 times b squared. Next, we have a to the 4th times 35 times b cubed. Then a to the 5th times 35. And this is a to the 3rd, not a to the 5th. I'm sorry, guys. So a to the 3rd times 35 times b to the fourth. Then we have a squared times 21 times b to the fifth. Next would be a to the first times 7 times b to the sixth power. And lastly, we have 1 times b to the seventh. So we're going to combine or multiply all of these to get a to the seventh power plus 7 a to the sixth b plus 21 a to the fifth b squared plus 35 a to the fourth b to the third plus 35 a to the third b to the fourth plus 21 a squared b to the fifth plus 7 a b to the sixth plus b to the seventh. So this whole thing would be your answer. For our next example, we have x minus 4 to the fourth power. So the first term that we have within that binomial is x. The power that we're working with is 4. So we're going to go x to the fourth, x cubed, x squared, x to the first, and x to the power of 0. The numbers from Pascal's triangle are what for the power of 4? 1, 4, 6, 4, 1. Our second term in that binomial is the negative 4. So we're going to keep the negative with that 4, start with the power of 0, then move to the power of 1, power of 2, power of 3, power of 4. From here, I'm going to multiply this from bottom to top. Just because my number is on the bottom and I want my number first in front of my variable term. So like I said, I'm going to go bottom to top with this. I'm going to cancel out my powers of 0. And then I have 1 times x to the fourth, which is just x to the fourth. Next, we have negative 4 to the first power, which is negative 4 times x cubed. Next, we have negative 4 to the second power, which is positive 16 times 6 times x squared. Next is that negative 4 to the third power, which is negative 64 times 4 times x to the first, which is just x. Lastly, we have that negative 4 to the fourth power, which is positive 256. So now from here, we just have to multiply. So that's going to give us x to the fourth minus 16x cubed plus 16 times 6, which is 96, x squared, minus 256x plus 256. For your next example, you have 2x plus 3 to the fifth power. We're going to start with that 2x. Raise it to the fifth power. Then we have the 2x to the fourth, 2x to the third, 2x squared, 2x to the first, and 2x to the power of 0. For our numbers from Pascal's triangle, what are they? We're going to start with 1, 5. What's the next number to the right, guys? So your next number is 10, then 10, 5, and 1. Your second term in your binomial is 3. So you're going to start with 3 to the power of 0, 3 to the first, 3 to the second, 3 cubed, 3 to the fourth, and 3 to the fifth. First thing I'm going to do before I start multiplying up or down, cancel out those powers of 0. Okay, so you have 2x to the fifth power. That 2 to the fifth power is 32, so that gives you 32x to the fifth. Next, you have 3 to the first power, which is 3, times 5 times 2x to the 4th power, which is 16x to the 4th. Next, you have 3 squared, which is 9, times 10, times 2x cubed, or 2x to the 3rd power, which is 8x cubed. Next, that's 3 cubed, which is 27, times 10, times 2x to the 2nd power, which is 4x squared. Next, you have the 3 to the 4th power, which is 81, times 5, times 2x to the 1st power, which is 2x. And then lastly, you have the 3 to the 5th power, which is 243. From here, we're just going to multiply. So that's going to give us 32x to the 5th power, plus 3 times 5 is 15, times 16 is 240x to the 4th power. You have 9 times 10, which is 90, times 8x to the 3rd power, which is 720x cubed. Then you have 27 times 10, which is 270, times 4, which is 1080x squared. Then you have 81 times 5 times 2, which is 81 times 10, which is 810. Keep the x with it, and then drop down that 243. For number 3, you have negative x minus 2 to the 7th power. So this one, we're going to start with the negative x, raise it to the 7th power, then to the 6th, the 5th, 4th, 3rd, 2nd, 1st, and the power of 0. From here, we're going to work with the numbers in Pascal's triangle. So we have 1, 7, 21, 35, 35, 21, 7, and 1. Next, we work with the second term in the binomial, which is negative 2. So you're going to have negative 2 to the power of 0, negative 2 to the 1st power, negative 2 to the 2nd, to the 3rd, to the 4th, to the 5th, the 6th, and the 7th. So from here, I cancel out the negative 2 to the power of 0 and the negative x to the power of 0. And start with the negative x to the 7th power. Before I do any of this, actually, I want to take care of my signs. The negative x to the 7th power is going to stay negative. The 1 to the 6th power is going to become positive because the power is even. Same thing with the 4th power and the 2nd power. For my negative 2 to the 1st power, it's going to stay negative. To the 2nd power, it becomes positive. To the 4th power, it becomes positive. And to the 6th power, it becomes positive. Because anything to the even power is a positive term. So we're going to have negative x to the 7th power, which is just negative x to the 7th. Then we have negative 2 times negative 7. Oh, sorry, negative 2 times 7 times x to the 6th. Then we have 2 squared, which is 4, times 21, times negative x to the 5th power. Negative 8, because 2 cubed is 8, times 35, times x to the 4th. 2 to the 4th power, we have 16, times 35, times negative x cubed. Then we have negative 2 to the 5th power is negative 32, times 21 times x squared. Then the 2 to the 6th power is 64 times 7 times negative x. And then we have that negative 2 to the 7th power, which is negative 128. So after this, we're just going to multiply. So we're going to have negative x squared minus 14x to the 6th minus 84x to the 5th. And you have negative 8 times 35, which is negative 280x to the 4th. The 35 times 16 times negative x cubed is negative 560x cubed. This is to the 7th. Thank you. So let's try it. There we go. And then from here, we're going to have a negative 32 times 21x to the 2nd, which is negative 672x squared. Then you have 64 times 7 times negative x, which is negative 448x minus 128. For your last question, working with Pascal's triangle, you have x squared minus 5y cubed raised to the 3rd power. So we're going to start with the x squared raised to the 3rd power. Then we have x squared raised to the 2nd, x squared raised to the 1st, and x squared raised to the power of 0. For your power of 3, we have 1, 3, 3, and 1. Your second term is that negative 5y cubed. So we're going to raise that to the power of 0. Then to the 1st power, the 2nd power, and the 3rd power. Remember, with these, you have a power raised to a power, so you need to multiply the powers in this case. We're going to cancel out the powers of 0, and we're going to work going vertically. So first column, x squared to the 3rd power is x to the 6th power. You then have negative 5y cubed times 3 times x to the 4th. You then have 25 y to the 6th times 3 times x squared. And then that negative 125 y to the 9th. So multiply whatever you have out. So to be x to the 6th power minus 15 x to the 4th power y cubed plus 75 x squared y to the 6th minus, hold on, 1, 2, 3, 2, 1, x, okay, 125 y to the 9th. There we go. So instead of you memorizing your Pascal's triangle, there is a simple way to figure out what it is. And I would be writing this on every single practice, quiz, or test you have dealing with Pascal's triangle. You're going to start your triangle with 1 at the top and 1 on both sides of it. That would be the power of 0 and the power of 1. For your second power, you're going to have 1 on the outside, 2 in the middle, 1 on the outside. So the 2 1s on both sides in the second row added to give you that 2. Next, you're going to the third power, so that's 1. 1 plus 2 is 3. 2 plus 1 is 3, and the 1 goes on the outside. For your fourth power, you got 1 on the outside. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and then 1 on the outside. For your next power, which would be the fifth, you got 1 on the outside. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and 1 on the outside. If you had to go to the sixth power, you got 1 on the outside, 6, 15, 20, 15, 6, and 1. If you had to do the seventh, you got 1, 7, 21, 35, 35, 21, 7, and 1. If you had to do the eighth, you would just continue to add. So the next part in our notes for 13.6 is our binomial coefficients. We do have a formula for these binomial coefficients. which is given to you in the next page or your next slide here. But something that I do want to go over is this n with this exclamation point. That is called n factorial, so that every time you see that exclamation point, you will read it as factorial. It just means that, like, let's say you had something like 4 factorial, you're going to go ahead and take that 4 and multiply it by everything that is less than that 4. So the 3, the 2, and the 1. Anything also 0 factorial is always 1. So like 0 to the power of anything, it's always 1. So your formula for your binomial is given to you with this n factorial over r factorial times n minus r factorial. That just means you're going to take your top number, multiply it by every number underneath it or less than it, over the bottom number multiplied by every number less than it, times your top number minus your bottom number. Whatever you get from there, you're going to take that and multiply it by every number underneath it. If we look at some examples, like our first one, we have 9 over 4. Another thing with this, you can look at these as combination factorials too. So this would also be written to you as something like sub 9, c sub 4. So your top number would be on the left, your bottom number would be on the right of that too. And it's just called a combination factorial. So with this, we'll have our 9 factorial over 4 factorial times 9 minus 4 factorial. That 9 minus 4 is 5. So ultimately, you have 9 factorial over 4 factorial times 5 factorial. This is just saying 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1 times 5 times 3 times 2, or sorry, 5 times 4 times 3 times 2 times 1. Your 5 down to 0, or down to 1 is the same on the top and the bottom, so we'll cancel those out. And we'll just do 9 times 8 times 7 times 6 over 4 times 3 times 2 times 1. So you'll be able to use your calculator with this. That 9 times 8 times 7 times 6 gives us 3,024. And the 4 times 3 times 2 times 1 gives us 24. So we can simplify these. The 3,024 divided by 24 should give you 126 as your final answer. For example B, we have 100 over 3, or our top number is 100, so we're going to have 100 factorial over 3 factorial times 100 minus 3 factorial. This will simplify to give you 100 factorial over 3 factorial times 97 factorial. So that means we have 100 times 99 times 98 times 97 times 96 all the way down to 1 all over 3 times 2 times 1 times 97 times 96 times 95 all the way down to 1. Your 97 to 1 is the same on the top and the bottom, so those will cancel, and you'll just work out the 100 times 99 times 98 over 3 times 2 times 1. Your 100 times 99 times 98 is 970,200 over 3 times 2 times 1, which is 6. If we divide by that 6, we are left with 161,700 for our answer. Your last example with your 100 as your top number, your 97 as your bottom number. Again, you would see this as sub 100, C 97, sub 97, so that way it's a combination factorial. That 100 is going to go on the top, and you'll have 97 factorial times 100 minus 97 factorial. This then will simplify to be 100 factorial over 97 factorial times 3 factorial. So we have literally the same exact thing that we had in the question before this, which means this is going to give us 161,700. So this part here is the same as this part here.